Hello, Jack.
Hello.
What's wrong? You seem troubled.
Yeah.
Well, if you want to know more about it.
Uh-huh.
Well, there are two separate parts of the brain, the left and right hemisphere. Yes, I know, it's wild. Even though you have two parts of your brain, you still put both to work.
Oh, man, this is hard.
No, not always evenly. For a smart guy like you, maybe the right side is even stronger. The primary connection between the left and right hemisphere is connected by a ribbon-like band of hair fibers under the cortex called the corpus callosum. Yeah. So do you want to know more about hemispheric specialization?
Oh, maybe.
Well, the hemispheres use close communication and work together as a coordinated unit. And the left hemisphere receives information only from right side of body and the visual field. The left hemisphere is unaware of any information from the left side of body and visual field. This is true for the right hemisphere and the right side of the body. Paying attention, Jack? All right.
Yeah. The right side of the body is the right side of
All right.
7.
So researchers think it also works with analysis, logic, and rational sequence. The right hemisphere focuses more on the visual, spatial, nonverbal imagery. An example of this would be music, face recognition, perception of emotions, etc. The left frontal lobe has more activity for cheerful, sociable, and self-confident emotions, and the right frontal lobe has more activity in stress, fright, and depression. Next on to language. Human language is controlled primarily by the cerebral hemisphere. See. In the 1860s, this idea was formed by the French physician Paul Broca.
¿Por qué?
Two major languages were discovered, Broca's area and Wernicke's area. Wernicke's area lies toward the back of the temporal lobe and focuses on processing and understanding what others are saying. Next, language problems such as aphasia and the impairment of the ability to use talking or understand language. It is probably caused from brain damage. Next is handedness. A common misconception of the hemispheric specialization is handedness. Being left-handed does not mean the right hemispheric is dominant and the left hemispheric is secondary. Right-handed people are more dominant in human population from the interaction of genetics, environment, and prenatal development.
I'm natal.
Tools to study the brain. Various methods are used to understand the brain. Observe patients who suffered from brain injury. Original method was remove or damage the brain of non-human animals and study the effects.
Dogs.
Modern basic techniques are microelectrodes, macroelectrodes, structure imaging, and functional imaging. Want to talk more about microelectrode technique?
Oh, better, yeah.
Microelectrode technique is a recording technique used to study the functions of the single neurons. Microelectrode technique is used to understand action potentials, the effect of drugs or toxins on the neurons, and even processes that occur in the neural membrane.
My membrane.
Macroelectrode technique is a recording technique that is used to obtain an overall picture of the activity in particular regions of the brain. EEG is flat electrodes that are taped to the scalpel. The electrodes are linked by wires to a device that translates electrical activity into lines on a moving roll of paper. Brain waves provide index of both the strength and the rhythm of neural activity. This technique gives valuable insights into changes in brain waves during sleeping and dreaming. Next is structural imaging. Researchers want to map the structures in a living human brain. Two new techniques, computerized axial tomography, or CAT scan, or magnetic resonance imaging. Computerized axial tomography scanning allows scientists to make three-dimensional images of a human brain without performing surgery. CAT uses X-ray photography that rotates around the person's head, making an image from top to bottom. Next is functional imaging. Researchers look at the brain's activity, too, as it actually reacts to sensory stimuli such as pain, tones, and words. Ow! EEG imaging measures brain activity by placing electrodes on important places on the scalp. This method is extremely useful to detect abnormal cortical activity, such as observing epileptic seizures. Two related techniques to EEG are MEG and magnetic source imaging, or MSI. MEG and MSI measure the strength of the magnetic field and identify its source with considerable accuracy. Next is position emission tomography, or PET, which is scanning and uses radioactive energy to map brain activity by injecting radioactive substance into the brain. When the brain absorbs most of the substance, it begins to decay. The brain begins to release subatomic particles, which researchers study parts of the brain that is most active. PET is used to investigate how our memory for words and images are stored in the brain and locate brain damage from the Alzheimer's disease.
What?
The newest and most powerful technique for recording activity in the brain is functional magnetic resonance imaging, which is also called fMRI. Functional MRI measures the movement of blood molecules in the brain, allowing neuroscientists to pinpoint specific sites and details of neuroactivity. Functional MRI is used to compare normal learners with children with learning problems, allowing researchers to identify the neurological mechanisms associated with deficit hyperactivity disorder, or ADHM, Huntington's disease, and disorders that involve difficulty controlling emotions. fMRI has debunked the myth of people only using 10% of the brain.
Okay.
So what have you learned so far, Jack?
MDRI and Paul Broca.
Well, let me ask you a question. What did you learn about hemispheric specialization?
My brain has a left-right side, and my left side helps my right side more. Then my left side helps my left side more. But my right side is my left side help more than the right side helps the right side.
That's correct, Jack. Now let me ask you, what connects the two hemispheres together?
I don't know, man. Tell me about that.
That's the corpus callosum. Like I said before, the primary connection between the left and right hemisphere. It's a ribbon-like band of nerves of fibers under the cortex.
Oh, man.
So what about the left frontal lobe? What did you learn about that?
It's in the frontal lobes in the front of my lobe.
Well, what does the left frontal lobe control?
Auditory and hands.
No. Actually, the left frontal lobe has more activity for cheerful, sociable, ebullient, and self-confident emotions.
I'm confident.
That's your left frontal lobe, Jack. Next is the right frontal lobe. What did you learn about that?
Hand movement auditory.
No. Right frontal lobe has more activity in stress, fright, and depression.
I'm frightened.
Yes. When you're frightened, it's your right frontal lobe. Next, what about language? Human language is controlled primarily by the cerebral hemisphere. Do you remember who I talked about in the 1860s? Who had formed the idea?
Ron Paul.
No.
Herman Cain.
His name was Paul Broca. And two major languages were discovered in Broca's theory. The Broca's area and the Wernicke area. Where was Broca's area found in the brain?
Cortex.
No, the Broca's area is found in the frontal lobe. It is essential for our ability to talk.
Words.
Let's go over some tools to study the brain.
Hammers.
Not hammers, Jack. Various methods used to understand the brain. Observed patients who suffered from brain injury. Original method was removed or damaged the brain of non-human animals and study the effects. Modern basic techniques are microelectrodes, macroelectrodes, structure imaging, and functional imaging. Next. What did you learn about microelectrode technique?
I'm a unicorn.
No. Microelectrode technique is a recording technique used to study the functions of the single neurons in the brain.
One neuron.
One neuron. Microelectrode technique is used to understand action potentials, the effect of drugs or toxins on the neurons, and even processes that in the neural membrane. Then we'll go over macroelectrode technique. It is a recording technique that is used to obtain an overall picture of the activity in particular regions of the brain. EEG is flat electrodes that are taped to the scalpel. The electrodes are linked by wires to a device that translate electrical activity into lines on a moving roll of paper. Brainwaves provide index of both the strength and the rhythm of neural activity. This technique gives you valuable insights into changes in the brain waves during sleeping and dreaming. So tell me quickly, before we move on, what did you learn from this section? Or what was your favorite part, Jack?
I like the ribozones, and I sleep and I dream all the time.
Do you know what it's called when you sleep or dream, or what part of your brain is working?
My left hemisphere.
Well, a way to record when you're sleeping or dreaming and what's going through your head and the neurons is called macroelectrode technique. Remember?
Connect and then put the in perfect place.
That's correct. And last but not least,
So smart.
handedness. Are you right-handed or left-handed?
This one.
That's your right hand, Jack.
I use it.
And a common misconception of being right-handed, of hemispheric specialization, is handedness. Being left-handed does not mean that the right hemispheric is dominant and the left hemispheric is secondary.
My right side's stronger because I use my right.
That's wrong. Just
What?
because you're right-handed does not mean that the right side of the brain or the right hemisphere of the brain is stronger than the other.
I'm enlightened.
Right-handed people are more dominant in human population from the interaction of genetics, environment, and prenatal development.
I love my natal.
That's right. Now over to the last section that we covered, which was functional imaging. When researchers look at the brain's activity as it actually reacts to sensory stimuli, such as pain, tones, and words.
Don't yell at me.
All right. EEG imaging measures brain activity by placing electrodes on important places on the scalp. This method is extremely useful to detect abnormal cortical activity,
Got cortical.
such as observing epileptic seizures. So now that we've reviewed, why don't you tell me a little bit about structural imaging?
It was house.
No house, Jack. It's simply when researchers want to map the structures in a living human brain. So let me ask you quickly.
You should have said that.
I said it plenty of times, Jack.
Oh, man.
So now quickly, before we wrap this up, I need to ask you something. Do you have Alzheimer's?
I gotta tell you something. I have Alzheimer's.
I figured you did, Jack. But thanks for...
I gotta tell you something.
what's
I
that?
got Alzheimer's.
I know, you just told me that. But we're going to go ahead and wrap this
I
up.
need to talk to you about something. I have Alzheimer's right now.
That's tremendous. Jack, we're going to go ahead and wrap this up, so thanks for reviewing with me.
Could you tell me something about the brain?
I just told you plenty.
I need to know about the brain.
I just told you about the right...
I have Alzheimer's. Heads up.